Hi, I'm Phil, and today we're going to look at the current generation of Lego rovers and robots. So this particular version is based on the Raspberry Pi build hat, and it was done in partnership with Lego. So let's have a look at one version of this, a kit put together by Waveshare. And let's just go through this mind map to explore what it does. So what it is, it uses a Raspberry Pi to construct a robot. And what's different about this particular version of it, it uses mecham wheels. So you could move it not only front and back, but also left and right. So you've got a lot more control over maneuverability. It also has a 5 megapixel camera, and looking at this combination, you can do multiple tasks while the rover is moving, and you can take pictures while it's moving. What's different about this? It's using the new interface called the Power Functions 2 connector and interface on the motors, and also on the build hat for the Raspberry Pi. It's got good communications, so we're going to look at a project that uses Wi-Fi to remotely control the motors and also to pick up the camera images. So I bought this over a year ago. So it was actually announced before Lego killed off the Mindstorms and EV3 line of robots. And I'm currently looking at this as one of the advanced robotic topics. So the simple robotics topics are based on the microbit, which only allows you to really do one task at a time, whereas in the advanced topics, we're looking at multiple tasks at the same time, and we need a more advanced operating system. So let's have a look at the hardware. So overall, with the Waveshare robot, it's based on blocks. So you get the basic block of parts, which is mainly the Lego motors, and they're actually using a very simple Lego motor here, the mecham wheels and the Lego parts. The Raspberry Pi build hat is included in the kit, together with a battery, a camera, and what you have to do is actually combine the block pack with the accessory pack. So last year I went for kit C, which includes the other blocks. That is, they all include the Raspberry Pi build hat, the power supply and the battery, but the C also includes the camera, and also it has all the other components, including a Raspberry Pi Model 4. So if we look at the build hat, I'm interested to see whether I have problems with other hats working in conjunction with this, but there is a guide that shows you which GPIO pins are used by the Raspberry Pi build hat. So this allows you to control up to 4 motors, and it's using a small Raspberry Pi 2040 Pico microcontroller, and there's a communications protocol between the Raspberry Pi and the Pico controller. Okay, so I'm using the Raspberry Pi 4, and just recently they've announced the Raspberry Pi 5. So you probably get better performance on Model 5, but that can be substituted. Now, I'm also, I purchased additional Lego motors, the extra large Lego motor, and also the large one. So both of these I'll be testing today, and I'm using two of the extra large ones for my front wheels on the construction. But there's even other options available to you. You can look at the motors in the Lego Spike kit, and there's large motors there, and I purchased a couple of those, and I'll be testing those in the future. So rather than buying the full kit from Lego, which is called the Lego Education Spike Prime kit, and there's also an expansion kit. Now, that combination is very, very expensive. If you actually look at it, you do get the motors, and you actually get a nice board called the maker's hat or the maker's plate, where your Raspberry Pi can go on. Now, we have an alternative solution, which is much cheaper than that combination. So I've also purchased some of the Spike sensors, including the distance, the light, the color sensor, and the force sensor. So I've purchased those individually, together with Lego parts. So rather than using the recommendations and WaveShare construction, I'm going to use a design based on these special parts and panels. And this makes it much quicker to construct. And I'm also using a Lego plate for the Raspberry Pi. Now, let's have a look at some of the software. So that's the hardware. Just close that, move across to our software. So one of the interesting things about this is that the package from WaveShare includes an image already for this kit, although I have to modify that. When I change the motors, I have to import different classes and use different methods on my motor control. But my installation, I've expanded that to include Node-RED, Scratch, Sonic Pi. So it can do other things. And I'm using connections to my Windows PC with Tiger VNC. And also I've got a file management system, which allows me to look at the files on my Windows PC. I have to brush up on my Python because the main development environment for software coding is using Python. And there's a couple of choices, lots of things you can do with communications. High level wise, you can do Wi-Fi control of your robot and have a look at images. But there's also low level control where you look at how the Raspberry Pi can control the Raspberry Pi Pico motor controller on the build hat. So that should be rather interesting. I found a lot of the software terms quite confusing, and the only data dictionary that was available was the one from Microsoft. So here I seem to have found the origin of where the system medium motor fields and methods are used in the Python programming. Okay, so let's have a look at the projects that I've been working on. So far, I've installed the operating system without any problems, worked straight away, which was really good. I've done a chassis build. Now, my chassis build for the robot is different from the WaveShare one. So we can see pictures of that in a minute. So my first project was to concentrate on the mechanical construction and do the unit testing for the cameras and the motors. So I went through a couple of phases on this, and this is my last build. So have a look at some of the photos on that. So we'll have a look at what it looks like. So this is what my build looks like. And that doesn't have, these photos don't show the top build hat, but almost everything else. So we'll just move down. So you can see the Raspberry Pi Model 4 with a heat sink, and the two shelves are convenient. So I can take off my Raspberry Pi quite conveniently. It fits on a Lego plate, Technics plate, and on the bottom shelf, we've got a battery that powers everything. So you can see the bottom using the simple motors, two on the front, and there's the camera on the front there too. So that's what some of the photos look like. Now we've got the build hat on top of the Raspberry Pi, and it's connected to the motors. So that's what the final construction looks like, just with two motors. And software-wise, we've got control over the camera. So we're here, I'm showing remote control, and the software for that is, this is what it looks like. And for motor control, we've got Python programs. So let's have a quick look at that. So if we look at the software for that, you can see that I'm using a library that includes the class system medium motor. And you have to change that if you change your motors. So very, very simple program. Okay, so we might have a look at the desktop. So all of this is still unit testing. And this is my arrangement for mounting the hardware on the desktop. So I can see how the motors are spinning without having to do live robot tests. And we might actually look at a working. So this is my working model, and the pictures I've shown you before on that. Now, looking at the objectives, I want to operate now all motors, forward and reverse. I want to activate the camera, do remote control using a web browser, and view the camera also on a web browser. Design-wise, I'll be using the Lego plates on my own construction, and I'm using, for hardware, the Raspberry Pi. I'm gluing the plate to two Technic beams, so they can fit on with pins quite easily, and I can remove that. So that's quite convenient. Motor-wise, motors A and B, I'm using the Lego medium linear motor, and for the motors on port C and D, I'm using the XL motor. Using the WaveShare power supply and battery, and I put an additional heat sink on. And I'm using the camera that comes with the WaveShare. So these are the additional components that I've purchased, and this allows me to construct a simpler and quicker construction for my chassis. Together with my desktop arrangement, you can see that over here. So for the build, this is what it looks like, but I've also got two more motors that I'll be adding to the chassis. So programming-wise, I'll show you some of the code on that, and it's just a modification of the code that WaveShare developed. So what I've done, I've imported two classes, the system motor, the system media motor, which WaveShare uses, but I'm also using the software from Raspberry Pi for its build hat. So here we go, just importing the motor library, and everything else is quite similar. And you can see that I can do got full motor control, and I've got camera control using this software. Okay, so the results, I got it all working, which was good. The mechanical construction was convenient. I've added on the Raspberry Pi, the battery. I've done the testing of the motors and the camera, and they all work quite well. It communicates. Okay, so I was quite happy with all those results. Okay, so just look at some of the references, perhaps even the good and bad points. The good thing is that it's a standard now, and a collaboration between Lego Education and Waveshare, and also the Raspberry Pi Foundation. It's got good support. The motor control works and is quite convenient. And it also has, even at the low level, you can do the motor control not only in Python, but you can do it in a lower level. And that has the potential of porting it to other languages like Node-RED. And even that low-level control has PID control. I've got some bad points, but quite limited expansion. You've only got 4 points, 4 ports, and you need more than that. If you've got 4 motors, that's it. But those ports are used both by motors and sensors. So that's a bit of a limitation, I think. It complements the Lego Education Spike primary set, and you can use the motors on that, but that's very expensive. Yeah, you're spending at least $660 for just the kit itself, and not the expansion kit. The construction of the Waveshare is a bit weak, and the published chassis from Waveshare is quite poor, I think, and takes a long time to build. So the one I've got, you can build within a few minutes. The motors they fit fairly poorly, and there's a lot of very shaky construction, such as the way that the batteries are fitted on. So the projects, while they're limited to these at the moment, I will be exploring if I can put additional sensors on. And again, if you're using the lithium battery, you have to consider the risk and manage that quite well. Okay, so these are my references. So Waveshare, Lego for the Spike and the Spike portfolio. You've got a number of ways of getting that if you want to go down that direction. Or alternatively, you can still use Lego Technic motors. And that's it. Stay tuned and you'll see a video of the performance of the desktop. This is my desktop version of the Build Me Car kit from Waveshare. It's similar to the Waveshare design, except I've replaced the front motors with larger Lego XL motors, still using the new format for the Power Functions 2. And just to explain the parts on this construction, right on top we've got a camera, and this is the original camera from the Waveshare kit. The actual robot itself is using ball steering for the front, but for the desktop version we've got 2 of the Lego XL motors, and they'll replace the ball steering for the front. We've got a Raspberry Pi build hat on top of a Raspberry Pi Model 4. And on the bottom, we've got the original motors from the WaveShare kit. And these motors are quite low powered, and they use the same interface. And that interface goes straight into the build hat on the Raspberry Pi. So it's using the new format. And just to show you how this all runs, the actual project is here, and there's a wiki. Now, we've departed from the wiki in a couple of respects. We've got a combination of motors, Lego motors, and we're running the example. We've modified the software, and if we want to go forward, we can do a web control, and you can see that when we press the button here, pressing the button, all the motors, the front and the back, are all working. And if we want to go backwards, we just reverse that. So you can see all these motors are working. We want to go sideways, and we still have camera control. So if we go back to our web browser, you can see the camera. And if I put my hand in front of the camera, you should be able to see it. There will be a bit of a lag as it comes in. There it is, my fingers. So it's detected the camera image on this configuration. Well, the next configuration is four-wheel drive with a real robot test.